Welcome to this session. This session, we have a problem to solve, which involves trigonometric substitution. So we say, solution, since the integrand is of the form square root of a squared minus x squared, then we have to make a trig substitution trigonometric substitution of x equals to a sine theta. And then we relate that the general discriminant is a squared, ours is 1 minus x squared. So it should not be hard to see that a is 1. Therefore, our substitution is x equals to sine of theta, because this just 1 times sine theta is just sine theta. Now from this, we have, when you say 1 plus x squared square root, 1 minus x squared, so the square root of 1 minus x squared is the square root of 1 minus, when you square x, you get sine squared x, which is the square root of 1 minus sine squared is cos squared. Square root of cos squared is cos of x. So the integral, and then also from this one, dx is cosine of x, cosine of theta d theta. So the integral 1 minus x squared dx is the square root. Now this part is the same as cosine of theta, and then dx is the same as cos of theta d theta, which will be the integral of cosine squared theta d theta. And to integrate this integral of cosine squared theta d theta, we use the identity 1 plus cosine of 2 theta divided by 2 d theta, so which is the same as a half integral 1 plus cosine of 2 theta d theta, and this will give you a half into theta. Integral of cosine is negative sine, so we'll have negative sine of 2 theta, but then we have to divide by 2. Just apply integration by substitution method here. Use substitution here, you'll be able to get this answer. And then plus c. But you see, also, we know from our trigonometric class that integral sine of 2 theta is the same as 2 sine theta cosine of theta. So if we have a half of sine of 2 theta, is the same as a half into 2 sine of 2 theta, sine of theta plus cos of theta. So which will give you sine theta and then cosine of theta. So replacing here, we have the integral of 1 minus x squared dx is a half theta minus a half, then this will give us sine of theta, cos of theta, and then plus c. But that's not the stopping point because theta is our own creation. So we have to replace back in terms of the x's that we had. So to do that, we remember that we started with saying sine theta is equals to x. So this is same as x over 1. Now if you draw a right angled triangle, so if this is theta, sine is opposite of hypotenuse. So this will be square root of 1 minus x squared. So from the same triangle, cos theta is the same as adjacent of hypotenuse. So this will be root 1 minus x squared. And since x is sine of theta, then theta is the sine inverse of x. So therefore now we replace into this integral, into these values, and therefore the integral of square root of 1 minus x squared dx will be a half sine inverse of x, and then minus so at this point here, so we had cosine of 2. So at this point here, the integral of cosine of 2 theta is positive. So remember, integration of cos x dx is positive sine x plus c is only integration of sine of x dx that gives negative cosine of x plus c. So change this sign must be plus. So similarly, this sign here is plus. And then it will be plus. Now a half cosine of x, I put sine of x is x, then cosine of x is square root of x, square root of 1 minus x. One minus x squared, and then plus c. So therefore, the final answer will be a half sine inverse of x plus a half x, and then the square root 1 minus x squared plus c. So this is the solution to our problem. Thank you.